Welcome to Open Networking TV. This is The Catch-Up. I'm your host, Art Fuel, and today we are going to be catching up with another one of the founding fathers of the SDN movement, if you will, Rob. I hope that's a fitting description. Rob Sherwood of Big Switch Network.
Thanks for having me. I actually have a background as a campus network admin. I was doing network security and network administration back at the University of Maryland 15 years ago. And then I ended up going through graduate school doing the network research, network security angle for my PhD, and actually ended up at Stanford as part of the Clean Slate program before SDN was really a thing. And so I was paid by Deutsche Telekom. It was also kind of a postdoc for me there, and I just ended up in the group that was doing OpenFlow. And I actually joined with Guido Appenzeller, the future founder of Big Switch, was actually my manager. We were just a couple of grad students, a couple of postdocs doing some funky things with networks. And later, SDN came about, and Big Switch came about, and Asira came about, and all sorts of things happened. And I've been involved basically ever since.
What's your takeaway? How do you feel about what's it been like, going through this experience and watching it all mature?
I've said every year for the last 6 or 7 years, next year is going to be huge for SDN. And actually, I'm right. And actually, after 7 years of it, it's getting a little bit scary. So practically speaking, there's a bunch of things that I think are really going to be different about 2015. The idea of disaggregated switches, bare metal switches, that I, as a vendor, a software vendor, can actually write my own software on the switch and then turn that into a wholesale SDN solution. I think that is really coming to bear, and that's really helping accelerate the industry. I've been talking about this for a couple of years now, but there's this inherent problem that building a good SDN switch side implementation is both technically hard, and the people whose job it is to do that are economically disincented to do that. We're asking them to throw away, in some cases, 20 years worth of software investment to implement this OpenFlow thing, and it's just not going to work. And so, putting the incentive in the right place, for a company like Big Switch, we actually now can produce our own switch operating system. We have Switch Lite; it's built into all of our products. We can tune the SDN stack the way that we want it to be, and actually produce good commercial products for people. And we're really starting to see a lot of evidence of that. And I think 2015 it's going exponential. So I'm pretty excited.
We've had this challenge in that we're expecting new things to come to us in a way that they've kind of always had, or at least that's what we're used to. And a lot of the new things are coming in ways that we don't expect. I think a lot of the ways that people will end up consuming SDN is actually going to be very different they're not necessarily going, some people will buy an SDN switch and deploy an SDN switch themselves as a typical enterprise customer. But I think a lot of the ways where consumers are going to benefit from SDN, it's going to fall in behind the scenes, maybe in some cases more, and be all over the place. But I'm curious about your insight on that.
Absolutely, and this, I think Big Switch did a pivot about 2 years back, and it really is exactly to the point that you're talking about, which is SDN. Before the pivot, we were treating it like a product. That is that, if we build the controller, then you, the consumer, can build applications and do the software integration to make this happen. And basically, the experience that we found, and I think the rest of the industry is slowly coming around to this, is very few consumers actually want to invest in software engineering, invest in the very difficult integration problem of trying to build up their own SDN solution. That's the domain for the Googles and Facebooks and Microsofts of the world, but not really for even the vast majority of Fortune 500 customers. And so what we're pivoting to, and what we did 2 years ago, and we're really starting to execute on this now, is exactly what you said, which is SDN as a technology where we provide the whole solution. We provide the user experience, the application, the controller, and the switch side operating system. And so that you, the end user, don't have to invest in a development team, try to figure out how to automate regression tests, and a whole bunch of things that enterprises just traditionally aren't interested in doing.
It's like everyone wants the benefits of SDN, and I don't think they care exactly how those benefits get implemented. What they really want is an ability to push the easy button, I think. And it doesn't necessarily have to be all that easy, but I think today we're in this environment where we're looking and saying, wow, look at this, some Google-like company does implement these really cool features I want. Oh, and by the way, they're investing hundreds of of people and maybe millions of dollars to be able to accomplish that, and there really hasn't been a good middle ground. It was like you either go really complex and trying to custom Linux OpenStack type of thing, or you're back to commercial off the shelf. And I think what you're describing sounds like the right fit. A way for people to get these benefits, but not have to do their own solutions engineering. Throughout every step.
And that's exactly it. I mean, the short version of what Big Switch is trying to do is trying to learn from what we call the hyperscale players. So not even the Fortune 100, like the Fortune 5, right? So what is Google doing, what is Amazon doing, what is Facebook doing? And then trying to figure out, okay, it's almost like treating Big Switch like the company's outsourced development firm. We will be the Google engineering team for you, so you don't have to hire them. And that means the technical challenge that we solve is actually harder than what these companies are doing, because they only have to solve it for one use case or a couple of use cases, where we have to solve it for all of them. But the net result is you actually end up with a more robust solution, something that takes into account a lot of use cases. It's actually pretty exciting. Customers are very responsive to, I want to do what Amazon does, but I don't want to have to do it the way that Amazon did it. And I think that message is resonating very well.
I don't think that the pace of innovation is going to slow down. And to me, it seems, the inevitable result is that there's going to be a lot of innovation. If you have a business that their job is making, widgets, they make toilet paper rolls, I don't know, right? That company shouldn't rightfully be focused on engineering the most efficient data center in the world, right? But they should be able to get those to get that performance impact. And in the past, it's never really been possible, right? And I think today with engineered solutions and especially with built on the new web scale SDN and framework, it really starts to introduce that type of possibility.
The other side of this, which people aren't talking about as much, but I think is really important, which is to say, the Googles and Facebooks and Amazon of the world, they are not networking vendors. They're only doing this because they feel like they have to, which is to say, the incumbent vendors that they would traditionally buy equipment from are not meeting their needs. And I think more and more people are finding that.
Out of all the different open networking summits, I mean, there were tons of really big, light bulb, aha, moments that has happened at all of those. And I think, possibly the biggest of all those was I think it was the first, maybe the second ONS, where Google got on stage and was saying, hey, we've asked every single vendor, and all the vendors, who, by the way, happen to be sitting there in the room, which is just hilarious, right? We asked every single vendor to help us build the type of switch we wanted to build. And every single one said no. And we had to go build it ourselves. And that was really great because we're getting over 90% efficiency on our WAN. And we are realizing all these powerful benefits that have been proven since to really be substantive in their strategic differentiation, which is interesting because networking for so long is plumbing. And now really in this past year, you've seen some really big articles from Facebook and from Google that have really attested to just how much strategic differentiation that Facebook and Google and some of those other companies have been able to get specifically from the network, which I think is a very fascinating point.
That's what people talk about. And when I pitch to people the benefits of our software, I actually tell them, the third interesting thing is actually the CapEx. And well, isn't that what the main point is? Well, no. So if you talk to most companies, CapEx is actually one of their least problems. One of their biggest problems is the OpEx cost, and their biggest, the number one problem is actually the network is actually holding them back. So if you talk to a large bank who makes money by deploying new applications, so some analyst somewhere comes up with some idea that says, we can do loan refinancing this completely different way. Let's do a web application. There's a pop-up when our users log into our bank account. It'll pop up saying, hey, have you thought about refinancing your phone loan this way, right? Mm-hmm. Deploying that application takes months. Yeah. And the limiting factor there is actually the network. And so the thing that makes the bank's money is limited by the network. And so, yes, CapEx is important, but it's not as important as OpEx. And even OpEx isn't as important as doing more of the thing that makes you money.
I don't want to get too detailed, but what is it about SDN in that context, right? I mean, we've got a lot of, especially compared to how we did traditional networking. We used to have to stick a access list on a physical switch port somewhere to be able to control policy in a way that was very not connected at all to application provisioning, and that's changing, right? I mean, that's very different in a big switch network. How does that work?
Two big things. One is, in traditional ways, people have to do box-by-box provisioning. So that is, if you want to spin up a new collection of VMs where some are on this side of the data center and some are on this side, you will actually have to log into every box along the path and update that configuration. And you better hope you don't make a subtle mistake, because you might have to then log into all those boxes again to try to figure out what it is. So having the automation to move from box by box to an automated setting, like that actually is a strict improvement, both in terms of speed and also in terms of, if you've got a computer actually making these changes for you, it's less likely to make a mistake.
If you look at what's happening OpenFlow today, OpenFlow in the physical hardware, there's a lot of people saying, oh, well, what if I just did an API here versus rather than using OpenFlow, maybe leave the control plane. But I think there's one point in there that's very related to the automation, but maybe a different level of sophistication. That is, first we need the automation because when we move virtual machines around, when we deploy virtual machines or other applications, we need that policy to automatically kind of follow that, right? And so OpenFlow can do that. I can do that through a number of other means. But I think one of the things about OpenFlow that's really key there is understanding the current exact state of what configuration, what policies are following that virtual machine or that application around at a given time. Because I think with SDN, as we get into this, appifying of networking, having the current state, it really becomes critical, right?
Absolutely, and I mean, I've definitely said publicly a number of times that I think OpenFlow is very valuable. It's a technical solution to a business problem that we had. So just to say, if you flash back 7-8 years when I started working on this, the idea that you could actually buy a switch and put your own software on it, and there was enough hardware documentation and enough open source software to make that happen, it just wasn't even on the table. And so the next best thing that we could hope for was a remote API into the low-level porting in the box. And that was how OpenFlow was designed. Fast forward to today, we have things like, if I can put a small plug-in for my open source project, Open Network Linux. It's a Linux distribution for
Please do, yes. We're big fans, right?
You can grab something like that and either deploy OpenFlow or write your own OpenFlow or write something else. We have people using it with protocol buffers, we have people using it with scripts, we have people creating their own custom protocols. And so OpenFlow, the concept, is extremely useful, which is let's expose the raw table memory to an RPC. But OpenFlow specific protocol, whether it's the OpenFlow or just something else that does that same process, I think as the open source evolves, as things like Open Network Linux take off, I think that specific detail will be less important.
There's all this language challenge around SDN, right? What exactly does SDN mean? Because in some cases it is only OpenFlow, in some cases it's only OpenFlow in the physical hardware, or in other people define it as these really broad things. And from my perspective, that all started from the first Open Networking Summit when as soon as SDN looked like it might be a hyped term, every vendor out there came back and said, what we already have today is SDN. That new stuff coming out of those star-eyed visionaries over there in the academic space, that's not really SDN. And what I saw is kind of as a result of that, there was a little doubling down on OpenFlow is SDN. But at the same time, you go to from the first ONS, it was always very, very clear. SDN is not OpenFlow. OpenFlow is not SDN. What we're really trying to do is change the industry and introduce the opportunity to have all different types of new thought and figure out what works best, and OpenFlow will be part of that. But I think from my perspective, I saw that seems to me like to be one of the sources behind some of the terminology confusion. And I hope today that's getting a little better. But I was just wondering if you kind of saw a similar occurrence over these past few years.
Absolutely. Actually, it's worth going back. So the article where the term SDN was first coined, I was actually interviewed for that article. That
was an MIT Tech Review. I remember that one, right?
And basically the thinking from the author's side was, well, this is a little bit like software-defined radios, because you can maybe change some of the networking things, so I'll call it software-defined networking. And so I always tell people, the term started out imprecise and didn't really get much better from that.
Well, that's interesting that you mentioned that, because I've been thinking the opposite, right? I mean, software-defined radio access networks, really, really cool tag, right? And I thought they pulled that term from SDN. Fascinating, thing to learn, right?
The thing that's a little bit confusing is networking has always been about hardware and software in combination, right? So if you look at how a router or a switch is made, there's a lot of absolutely dedicated hardware there, in terms of an ASIC or different types of forwarding memory and whatnot. But there's also a lot of software. And so, if you went to a traditional vendor and said, okay, we're now going to make the network software defined, they're like, well, we have a huge software team. We actually write a lot of software. What does that mean? Now, the term that the definition that I like, the one that the ONF supports and that ONS supports and things like that, is there's actually a controller involved. So there's a remote controller making RPC calls down to individual switches. And what those RPC calls are they open flow? Is it open flow like? I think that is almost an irrelevant implementation detail. That is the idea of providing some sort of abstracted view of the network via a hierarchy.
So the interesting thing about that definition is I just wonder, what is the line between management, automation, orchestration platform and a controller?
And so there's a critical difference, and apologies in my mind if I get too technical, but it's
please.
about managing the forwarding memory. Mm-hmm. So much of those configuration things will actually set configuration parameters in individual switches, but aren't actually, and those might indirectly affect forwarding decisions, whereas in my mind a controller actually affects the forwarding decisions directly by actually populating the forwarding memory directly. So the analogy I always make is if you look at a multi-line card switch, these are the big iron boxes that everybody has. They almost always have a couple supervisor modules, some line cards, and some fabric backplanes. Mm-hmm. And so if you look at the protocol between those supervisor modules and the line cards, there actually is a protocol inside that box for, if a new route comes in, how do we program the line cards? And I call that protocol closed flow, because it functions like open flow. The supervisor cards are just like controllers, and it's the idea that you can do this in at least a somewhat open way. That's the thing that's fundamentally different. It's not architecturally different. It is just that something that was closed is now open. That's the difference.
I think that's especially for the people who are just getting into OpenFlow or just getting the first hands-on experience with them. That's a really powerful analogy. In networking, we tend to be perhaps the most risk averse of a lot of people who work in IT, because everything goes down when the network goes down. So no amount of high availability you build into your important app matters when the network's down, right? And so, as we are familiar, though, if you've been in networking, with these big chassis switches. We've used them a lot, right, for a lot of years. And if you look at, like you said, to your point, how those work, right? You have the forwarding decisions and essentially the forwarding database managed by the supervisor, and it especially in modern chassis where you're using distributed forwarding, right, it's going to cache essentially the decision engine on each individual line card, and that line card goes ahead and makes the forwarding decisions, assuming it has an entry, right? It runs, and you take OpenFlow, it's the same thing minus the chassis, just like you said. And I wanted to highlight that point. Anyone who's feeling uncomfortable with the idea of OpenFlow, it really is very comfortable dynamic. It's a very similar type of, there's a lot of new things about it, but there's a lot of comfort points in ways that it's similar to traditional architecture as well for those getting into it. Now, I guess along the lines, do you have any other kind of guidance for people who are just getting into OpenFlow to come to wrap their heads around the significance and how it'll impact their operations?
Another big one that people talk to me about is support. So people get a little bit concerned about support in a disaggregated model where you might buy the hardware from one company and the software from another. And so, I tell people, talk to your server people. Ask them how they buy their servers. Because the server people have the same problem, and it's not a problem. Which is to say, you can, if you want a single cartridge token, you can pay for that. If you want to buy both through the channel, you can do that. If you want to buy through a reseller, you can do that. If you want to buy direct from the hardware manufacturer and have them support the software, that also works as well. And so, it's a little bit like everyone's running around saying everything's different, the sky is falling, and I actually spend a lot of my time trying to convince them, actually, this is pretty much the same thing we've been doing already, just only networking has been different. So you mentioned briefly, everybody's worried, network engineers are very conservative because when the network goes down, everything goes down. That is strictly the function of the extremely tight artificial coupling of how the software is set up. And so if we actually built networks the way that we built distributed web applications, we wouldn't have that problem. And that's a lot of what the Big Switch is trying to do, is actually build these things a little bit more like distributed web applications, so that if you lose a piece, it's not that big a deal.
And I think that's kind of core to the spirit of architecture, right? It seemed like for a long time people would try to engineer individual components to never ever fail no matter what. And somewhere along the way, as we got into web scale, we realized individual components are always going to fail. We have to build an architecture that can tolerate a lot of failure and still keep on running and without a hitch, right?
This is exactly the same transition that people went through, moving both from mainframes to PCs, and really from supercomputers to data centers. So if you look at the architecture of a modern data center, people are starting to build them effectively exactly like supercomputers. So people talk about deploying a pod, and that would be one supercomputer node. And the idea of moving from hardware that can never fail to hardware that we know is going to fail at some probability, and we're just going to write better software. It is a tough pill to swallow, but it's one the industry has swallowed a couple times, and I have a lot of faith because I think it's just an economic reality.
In 2015, SDN is going to become a lot more accessible to a lot wider range of audience, because solutions like Big Switch are becoming more mature, easier to adopt. You've got other things that are finally really becoming within enterprise grasp this year, NSX, for example, and other NVO solutions. So I think this is going to be a year where a lot of different rubber hits the road, and I'm curious, what do you expect to see from the fallout of some of that stuff this year?
I definitely think, if you look at things like the traction that NSX is getting, you'll actually see a fairly big tussle in the underlay space. So it's actually a use case that Big Switch is looking at fairly closely. We provide a centrally managed physical fabric that you can run overlay over top of us, so we can actually be the underlay to NSX's overlay. And so that's an interesting space. Mm-hmm. At the same time, if you look at some of the recent work that they've done, OVN, Oven, they're calling it. Mm-hmm. So they're actually seeing a commoditization push that's already happening in the overlay space, where you get folks like Medicura, you've got folks like PlumGrid that are open sourcing and actually really trying to go after NSX in the only way that they can, which is, let's be a little bit more open.
OpenStack today largely uses a non-SDN framework. There's Neutron available. A lot of the production implementations aren't using that. And if you go to look at Neutron, who actually, I think there's this thought is, hey, I can go get OpenStack and I can deploy open source SDN with that. And that's not exactly a reality today, right? Because you go, particularly with overlays. As if you look at what's available from an open source overlay perspective, it's pretty much Open vSwitch, which doesn't have much of a framework yet. They're working on that, right? And then you have something more comprehensive like NSX and the Medicura and PlumGrid. But there hasn't been this, open source complete NSX-like framework for NVOs. And I'm familiar with at least 3 different products that are going to release NVO and physical OpenFlow as well in there this year for open source for the OpenStack community. So that'll be an interesting inflection point once there's more, let's say, NSX competitors of similar breadth available open source. I think this year.
I'm really happy with where Big Switch is from a product and a positioning standpoint because of that. Because I think the whole NVO market. The joke, and so Big Switch actually historically, this pre our pivot, had an NVO product. Mm-hmm. And my joke is there's an argument about how big that pie is, and I'm actually convinced it's not as big as people think it is. But it's clear that there's going to be a lot more people trying to get a bigger slice of that pie. And so that's why I'm happy that Big Switch went to the physical fabric side.
And if you look at VMware, what is their biggest strength? Their biggest strength is that everybody in enterprise and their dog has vCenter sitting in there waiting to be, potentially upgraded. And, if you're VMware and you're thinking, I want to sell, private cloud technology to all these people that have this stuff, it's not really necessarily in their business interest per se to say, oh, hey, everybody, to buy my next piece of software, all of you need to go out and buy, an entirely kind of new and different type of physical network to go underneath. And so I think, on one hand, there's a lot of technologists who believe in NVO technology very passionately, right? And I'm not slighting the technology at all, but I do think there's something to be said that for certain vendors, there definitely is a business interest there, where using an overlay, SDN overlay versus using an SDN underlay, could potentially conflate, the motivations.
Absolutely. But at the same time, so if you look at our typical customer, they've got 5 to 10 new projects in flight that all require new hardware, like new switches. So we're not actually we're not doing rip and replace of old gear. It's, take your legacy stuff, leave it where it is. Our stuff will slot into the row next to it, because they've got a Hadoop project, an OpenStack project. Maybe they're doing something with VDI, something like that. And so it's not so much a rip and replace. And honestly, that's just not a reality of modern data centers. Modern data centers is the lifetime of gear is probably 5 years. And so many people are expanding so quickly, throwing out older gear that's 3 plus 5 plus years old, depending on the company. That I actually don't think that deploying new hardware is actually a significant problem.
No.
As long as as it does with the Big Switch stuff. Obviously, there's interoperability. You can talk from the old stack to the new stack. Everything speaks IP. There's no problems there.
Yeah, as open networking takes hold, it looks to me like innovation in servers, innovation in networking. These manufacturers are really wrapping their hands around all three now. It's not just I make networking manufacturer, I make server manufacturer. And I tend to think, if I buy a new server network combination today to try and get my most efficient private cloud combination that I can, 3-4 years from now, I'm probably not just going to upgrade the server because the pace of that network innovation is happening. We're getting 100 gig and this is going to be 400 gig, and not to mention the other feature capabilities. I tend to think that we're going to see a lot more of this type of architecture where this year I'm going to deploy this private cloud, and maybe a few years from now, or as we get into the next paradigm, we'll do the same thing again. We'll stack up another new one. I'm curious, do you see that as an architectural trend?
Absolutely. So much so that we started running with the term we've heard from our hypercenter friends, which is core pod design.
Mm-hmm.
So the idea is you have a routed core, which is your egress and ingress to the data center. That lives through the lifetime of the data center, so that might be there for 10 years or whatever that number is. And then you have a lot of pods hanging off of it. So a pod is a collection, think of it almost like a row, but it's a collection of compute, storage, and networking gear that's all certified to work together. Mm-hmm. And the most salient point about the architecture is you've got a team whose job it is to constantly be working on the new pod design. So you'll have the pod design V5. And while V5 is the latest, greatest, every time you need a new project, you'll stamp out another pod of V5. And then while the team is working on it, they'll figure out, okay, what is the next best version of compute, of storage, of networking? How does this all bundle together? What is the next design? And when V6 comes in, they'll stamp that out every time they need new projects. So this is kind of multi-use, multi-purpose architecture, so it can have lots and lots of workloads in a pod. But the real value is actually in the automation. Mm-hmm. So if you are willy-nilly hooking up, every time there's a new rack deployed, if you've got new servers, new storage, new network, the automation of that is horrible. But if you actually have some homogeneity, which is to say, I know this is pod V4, then I can, that's much, much less complicated to manage. And that's where people are really seeing both the value from a purchasing standpoint as well from an automation standpoint. It's definitely a huge shift in how people are building data centers.
So you're an enterprise customer, and you're looking at deploying, let's say, private cloud technology. You want to have things that are automated and elastic and what have you. And what is your take on physical open flow and physical hardware versus NVO? If I'm a customer, do I use both and they interact at some place? Do I choose one or the other? Why? What would your advice to customers be around that?
So there's two dimensions, which is one is what is your workload, right? So depending on your workload, you can probably virtualize it, but you may actually have some physical hardware as well. For example, some database servers and things like that. Most customers that we talk to have kind of a 70-30 split, which is to say about 70% of their workloads are virtualizable and about 30% are physical only for various reasons. So understanding your workload is the first place to start. Most people end up with some sort of mixed workload or can't know ahead of time. And so the answer is you'll probably need both. And the other side of it is it's not really an either-or decision, which is to say, if you have an MDO solution, the packets don't magically get from one vSwitch to another. You need a physical network there. And if you're going to need a physical network, the question is, even if the automation, even if the policies are maybe not that complicated, having a single point of control across 40 switches is still easier and cheaper and better.
I'm a fan of NVO technology. Don't get me wrong. I don't have really an opinion on it one way or another. Sometimes I think, would the world really be that much of a different place if Betamax had won instead of VHS? At the end of the day, and don't get me wrong, I'm not saying they're the same quality of technology. I'm just thinking it's probably possible to make either one work if that's what the industry, chooses to put its weight behind. So I think I'm kind of waiting to see, is one going to take over from the other? But to my point, I mean, one thing that seems apparent with OpenFlow and the physical hardware is, sure, today, it hasn't been to full maturity yet, and I can't just go out as an average enterprise, go buy a plug-and-play solution. That hasn't happened yet, but that doesn't mean that OpenFlow technology won't ultimately create that. And once I have OpenFlow technology in my physical hardware, then is that, NVO stuff start to become overhead that you don't need anymore.
And if I can push back a little on what you said, I mean we've been shipping OpenFlow-based solutions that really are plug and play for the better part of 2 years now, particularly our Big Tap product. That really is a drop-in, goes on the side of your network, very safe. My joke is it's my first SDN project. It's a very safe, easy thing to do. And we're getting a lot of traction with that. So that builds on OpenFlow. We've been deploying that for a couple of years now. We've been deploying our Big Cloud Fabric product since September of last year. We're getting a lot of traction with that. Actually, our new release, if I can put in a plug for that, is about to come out this month, and it's going to actually support hardware from Dell, so we're really looking forward to that. Anyway, I think for 2015, it's going to be very interesting to see. Now that we've got some real initial customer traction, we've got some real products there. We're starting to connect all the dots and show the hockey puck curve. It'll be very interesting to see what happens this year.
The next thing I wanted to ask is really about Docker, right? I mean, that's one of the big new, fairly uncharted territories. Linux containers have been around for a while. The networking capabilities within Docker aren't particularly robust yet. There's a lot of startups trying to tackle that. And I'm certain, it's on your guys' radar and you're working on stuff, around that. And I'm curious, what do you see as, how's Docker networking going to hit the market and what evolution needs to happen there?
What's fascinating to me is, Big Switch has a virtual switch. We're shipping it productized, later this year. The virtual switch literally cannot tell the difference between a VM on one side versus a Docker image. So the way that the Linux virtual Ethernet pairs works and that type of thing. From a networking perspective, Docker really doesn't change much. You still need something that looks like a vSwitch. The more functionality that vSwitch has, the better. It actually increases, if you want to think of it in these terms, kind of the VM density. So you can actually get much higher density with Docker. You can spin them up a little bit faster, so they're a little bit lighter, so maybe there's a little bit more churn on that side. But a lot of the fundamental policies don't really change. Which is to say, most people treat collections of VMs as an application. Docker just lets you do that faster, cheaper, more. But all the policies and the user experience and the management objects and things like that, all of those things really stay the same.
Oh, that's great. I mean, it just seems that's ultimately, as particularly for the enterprises. I mean, if you're at the bleeding edge as web tech, you're going to see a lot more of the warts of the technology, if you will. But I think particularly for the enterprise, it seems to me that things are getting really streamlined for Docker to where pretty quickly, the management orchestration stuff that surrounds VMs today will probably be equally applicable in most systems for Docker containers, tomorrow. Does that sound about right?
Yeah, absolutely. And it's honestly, definitely I see the data center industry converging in terms of storage, compute, networking, all these things. But the people are still learning the skill sets. And honestly, I think it's the case that the companies are coming up to solve specific problems and are not necessarily aware of the problem from the other sides of the fence, as it were. And being able to bring the solutions wholesale from their side of the fence, I think will really help accelerate the adoption of these types of technology.
If you're a business, you need to take part of this Internet of Things thing, right? Pretty much no matter what product you make, you're probably fit in that somewhere. And you need to be aggressive, you need to be innovative. And it seems to me open networking SDN is really key to that. I'm curious your thoughts.
Absolutely. Honestly, that's actually what gets me up in the morning. That's really what motivates me, which is, you look at the explosion of applications that happened when all of a sudden people could write before smartphones, or even further back when people, when moving from mainframes to PCs, when people could write their own programs. You're actually enabling everybody in the world to become an innovator here, and it'll be fascinating to see what happens. At the same time, Internet of Things, there's kind of unprecedented security issues. The idea of having my toaster or my garbage disposal online is a little bit scary.
I mean, just to if I could interject something there, like kind of to that point about the toaster, like at the Consumer Electronics Show this year, there's little things like now the Roombas, instead of just being a vacuum, they're remote controllable and have a camera. And I don't know if it's the Roomba brand, but most of the ones at the show floor that were similar to the robotic vacuums, they have a camera and they're meant to be like home security system integrated now to where when you're at the office, I can tap into my Roomba, drive around my house, view everything in my house. It starts to really, that's even still a very, very small example, but I think it kind of highlights your point about the security implications. Any hacker can now not just get into our personal information, they can come into our house. That's a problem, right?
Absolutely. I think, I was saying, security is kind of a big world with a big tent, but what it translates to, more specifically, what we're talking about is more and more complex network policies. So who can access that camera during what time of the day, from what networks, and things like that. And, I think those have become kind of as those security policies compound, that's really what makes network management so complicated, and that's what I think really forces us to network automation, because I think that's really the only sane solution to this.
I think it's a great seg to end in there. Thinking about this Internet of Things, this realization that every business, no matter who you are, you're going to be part of this, and to win in it, and to hopefully win these 50 billion new devices and 5 billion people that are going to be coming on the internet over the next year. It's a lot of opportunity to win in it. I think open networking, software-defined, modern web scale architectures are the only things out there that really give you that flexibility. Big Switch is I think you've been really the first and the main one that really stuck to the core of what OpenFlow. I think great solution. Look up Rob. Well, I'll put the links up here to follow him. Thank you, Rob. Really great advice for the audience today. It's been a great conversation.
You're absolutely too kind, but thank you so much for having me.